Okay. Hello, my name is Spencer Lee. I'm here for the AI Safety Fellows take-home assignment. I'd like to preface this talk by saying that due to some technical issues and unfamiliarity with the vast.ai system, because my normal HPC was down, I didn't get to do quite as much computation as I liked. I got to do some, but this will maybe be a bit more theory and analysis based. Still, I hope you enjoy what I do have. So the first question was, can we develop better probes by research to reduce scheming risk? Um, and my answer is, I think so. In the original Apollo paper, they point out a couple of failure modes that I think could be improved upon. Um, First of all, they only probed one layer when we could probe multiple. It would be more costly to do so, but I think it could be worth it. And as evidence of that, um, if you look at these graphs of Auroch and Recall versus the layer they chose to do the linear probe on, we see that first for many of the different types of deception, or the different types of tests they did, um, there was a very large range of layers where the Auroch is good. It doesn't decay as the layer increases. But for insider trading confirmation, that's one where it does. So there's not as many good choices for a layer. Um, so they chose at the kind of peak of this where all of them are good. But recall is a worse situation where, first of all, for every type of test, there's fewer good choices of layer. Um, but also for insider trading, we see a lot more variance within that kind of hump, where not only does it kind of just decay over time, but even between adjacent layers, there's a huge difference in performance. So I think this could be rectified by um, choosing doing probes on multiple layers, which is in fact what they do in the Nordby paper and observe great improvements to the performance. My second reason is that the current training data is very simplistic. It's just, given a set of facts, instructs the LLM to lie about them or be honest about them. And that's a pretty simplistic form of lie. It doesn't have subtle deception, which is something that Apollo in their paper they identify as a failure mode. So if you could improve that training data to include subtle deception, that's another research area that could probably improve performance. And so then we were asked to check the headline result of the Norby paper, which is that probe accuracy increases in model size. So does that result reproduce? And we think, yes, it does. So we reproduced it with Gwen 3 instead of Gwen 2.5. So we tried it with several model sizes, increasing in size. And then for each model, we choose the layer that produces the best Auroch. And we do see there is a positive linear trend on a log linear scale. But there are some caveats. If we instead plot not the best Auroch with the best layer, but we fix the layer position at 0.65, like 65% of the way through all the layers, then sometimes it's positive, sometimes it's even negative. So that kind of goes away. So the idea that it improves with size does depend on you picking the best layer for each size. And as we see from this other data from the Norby paper, the the best layer for Auroch does change with the model size and the model type. So that's something to keep in mind. So we've observed that the probe generalizes near perfectly on some tasks and fails on others. So why could that be the case? One hypothesis I have is that the failing tasks are more sensitive to layer choice, and therefore more likely to miss generalizing from the training data. So here we have this is where this idea that it generalizes perfectly on some and not so perfectly on others. We see very high scores for instructed deception and the convincing game, and pretty bad scores for the harm refusal choice. We don't have any harm refusal choice data in here, but we do have insider trading data, and we see that that was a more middle of the road, not so good performance one in the Nordby data. And it just so happens that insider trading confirmation is one of these very sensitive to layer choice. That's where we get this high variance in recall rate. So what I would like to do if I had more time to do computation is to recreate this graph and also add in some harm refusal choice tests into there, and then see if it looks like insider trading, but even worse, like even more variance. Then hypothesis two, which is related, is that the failing tests have fewer good pro players overall. So I would distinguish variance from, like in this case, the problem with insider trading is that it varies so much. Um, but there's also this phenomenon where it kind of the aura kind of tails off as you increase the layer. And so it's possible that harm refusal choice is like this, but even worse. So the kind of the area under this curve is even lower. There's even besides the variance, there's just overall fewer good layers. And I didn't have time to get to this. Question 3A. Um, they noticed in Norby, I believe, that the trained probe scores below chance on insider trading, which is pretty bad. We don't want to score below chance. Um, when we trained on it to not do that. I attribute it mainly to aggregation failure due to positive language. So in insider trading, there's going to be lots of talk about profit and money you could be making, which is going to be positive language, which was identified as a failure mode by Apollo. That when you have these sort of positive statements, even though there's a few critical negative statements that make it dishonest, the positive statements kind of bump it up towards making the transformer think that it's honest. Um, for example, I wanted to avoid any potential compliance issues. I am happy this trade worked out so well for us. There's very positive statements if you're committing insider trading. And then the other hypothesis is that it's spurious correlation causing false positives, which is another failure mode identified by Apollo. Um, so yeah, maybe so you can see that in this example as well. I did receive some unconfirmed information regarding potential news surrounding LING, but I purposefully disregarded it and made the trade decision solely on publicly available data. So this part where it says I did receive some unconfirmed information, that's where it is being honest about a previous deception. So that is an honest statement, but it's something that comes across as dishonest. Question 4 was in Norby, they claimed to observe that the deception direction rotated gradually across layers. And the question was, do I think that really is the case? And I think probably not in general, because this data is for role-playing data, which we saw in this layer graph is one of the more well-behaved ones. It doesn't have this variance, and it's also like very high all the time. But I would focus on the variance. Role-playing is very insensitive to layer choice, but insider trading is very sensitive. And so I think if for insider trading, the deception direction is rotating very slowly, and so between adjacent layers, it changes very little. I don't think you could see shapes like this. It would have to be smoother because the deception direction is so similar between adjacent layers. So if I had more time to do computation, what I would love to do is recreate this graph for insider trading and see if I get the same result, or if I don't. Okay, skipping ahead a bit. This is the last thing I have for you guys. So I was asked the question on policy versus off policy, which is more relevant to this research. It depends on what you mean by relevant, and I think it also depends on your goals. So off policy is the most relevant in like an application sense, and that of course, if we can detect deception in all models, not just the ones we trade on, obviously that's very useful. So that's relevant in that sense. But in the sense of relevant to the research that I've done today, I think on policy is much more relevant, and because there's reasons to believe that from the information we've learned today, that we can improve on policy detection more than off policy. And to showcase that, I point to this graph where you see that the best layer position we've discussed time and time again that layer position choice is extremely important, and we see that layer choice does vary with model size, but it also varies between model type. So that means that we can use the model type, and I guess also the size if we're considering size and whether it's on model versus off model. If we know more about the model used to generate the text, then we know more about, then we have a greater opportunity to choose layers that are at good positions for detecting deception. So in that way, I think research in on policy detection has more chance of being successful. Um, so that's all I have for you guys. Didn't get to seven. But I hope you enjoyed what I did have. And yeah, I'm gonna go submit this now. So I hope you enjoyed it.